Dear students, welcome to another day's lecture in Industrial Engineering and Quality Control. We were discussing about work study and method study. In the method study, today let us start with recording techniques. See, when we are studying the method, it is the activities are required to be critically examined, and therefore we have to use some recording techniques to record the various activities, because just by looking with the naked eye you will not be able to properly understand each and every minute activity. So we have to record them, and therefore we are going to use some recording techniques. What are those recording techniques? Now we will see. Okay, and when the method study will be successful only if you record these things accurately. All the facts should be recorded. Okay, and it should be recorded very clearly and concisely, and these are the techniques that we are going to use now. Number one here is process charts. These process charts, they indicate the process sequence. The process charts can be further classified as outline process chart, flow process chart, and two-handed process chart. Okay, these three types. But in this flow process chart, there are further three types: man type, material type, equipment type, flow process charts. Okay, these are the process charts. Now there are on the basis of time also there are some charts, time scale charts, which are used, which use time scale. Okay, under this category are two charts. One is multiple activity chart and SIMO chart. Okay, you see, we're going to study all these recording techniques. Okay, so at present we are only listing these activities, these techniques. Okay, now in the third category are diagrams which indicate movements of various things, like it can be raw materials, or it can be raw material, finished semi-finished goods or finished goods, or it can be tools or equipment, or it can be people also. All those movements we can see, we can record, we can okay, the movements of those people. So in this category are following diagrams: flow diagram, string diagram, cycle graph, chrono cycle graph, and travel charts. Okay, we will see all these things. Yeah, next let us come to the first one, that is process charts. Okay, so what are these process charts? These process charts represent the process. um, the name itself shows it is a process chart, so it shows the process. Process means what? It can be the procedure, or it can be the method of doing the things, or anything like that. Okay, in process chart, the major activities that are we perform on the raw materials or any other thing. Okay, and the transport of the materials, these are recorded to have a graphical view of the activities. Why graphically, pictorially? Because we can easily visualize them. Okay, if it is in the graphical form. Okay, a process chart portrays the process with the help of symbols in order to understand the process in a better way. Okay, so when we are using graphically, then we need some symbols to represent. So what are those symbols? Process chart symbols, let us see. As symbols produce better picture and quick understanding of the facts, so symbols are used for charts. So symbols are very convenient and widely understood, um, like a shorthand. They are understood. They save a lot of writing. You see, one simple diagram, one a little symbol may be replacing one whole sentence, like that. So symbols for various activities are shown in the figure following. Some figure I'll show you later. Okay, and these symbols are recommended by ASME, American Society of Mechanical Engineers, ASME. Okay, and we are going to use those symbols. Okay, next, So first symbol is the circle. Circle is used for operations. Operation means it can be an activity, or it can be, like anything. Okay, any activity. Okay, this is represented by circle. O for operation. O for operation, you can easily remember. Okay, we use a circle. It indicates the main steps in a process, method, or procedure. The part or the material or the product concerned is usually modified or changed during the operation. You see, when we are saying what can be classified as operation and what is not, you see, if some modification is taking place, suppose you are taking raw material, on that you are turning it, you see the dimension is getting modified. Okay, so some modification is taking place. Okay, or you're doing some welding on it, so some material is being added there. Okay, like that some modification is taking place. If modification is taking place, then you can call it as operation. Examples of operations are, see, operations on machines like turning, grinding, drilling, etc., the welding, brazing, riveting, fastening, etc., loading, unloading, polishing, bending, assembling, all those things. No, these are all coming under operations. Okay, now inspection, second one. So for inspection, the symbol here used is a square. Okay, this inspection, why do we do inspection? Inspection is for quality. It is a quality check. Okay, it verifies whether the operation has been correctly carried out or not. You see, suppose we are filling air in the motorcycle, a motorcycle tire. So we have to check with the Bourdon pressure gauge how much is the pressure there. Okay, that's an inspection. Okay, you are checking with go gauge, no go gauge, that is an inspection. Okay, you are counting how many students have come into the class, that's an inspection. You see, all such things are inspections. See, unlike operation, inspection does not take the material any nearer to the completion of a product. See, operation is one in which some modification is done, or at least it is moved a little closer to the finished product. you know like like that, because why, if you are saying about loading and unloading, you know but all the other things, some modifications are taking place, but what loading and unloading are doing. Okay, that's why they have, in this definition they have said, it takes material nearer to the completion. Okay, anyway, so unlike operation, inspection does not take the material any nearer to the completion of the product. Here nothing we are doing, adding or modifying or changing the thing. Okay, so such thing is inspection. Examples of inspections are the dimension check. Suppose you want to check your turning operation on a lathe machine, whether it is 50 millimeters or not, or if the width is 10 mm or not, you want to check. Okay, so that is a dimension check. Okay, that is an inspection. And visual inspection, like you're welding. Okay, full welding is done or not, you want to check. So that is a visual inspection. Or any cracks are there or not, you want to check. So that is a visual inspection. Then physical count, you want to exactly count how many things are there. So these things are some of the examples of inspection. And for that, what symbol we are going to use? We are going to use a square. Okay, next one is transport. Transport, this is the symbol, arrow mark is the symbol, and it indicates the movement of workers, materials, or equipment from one place to another place. Okay, it can be, mostly it is raw materials, but it could be equipment also, it could be workers also. Okay, this is a transport thing. Then next is temporary storage or delay. See, when you are saying temporary storage, then permanent storage also will be there. Okay, that we'll see later. Now at present we'll see what is a temporary storage. Temporary storage, the symbol used is capital D of the English alphabet. Okay, it indicates the delay in the sequence of events or objects being laid aside. Suppose your raw material is waiting between two consecutive operations. you know Example here it is given. See, workpiece is lying on the floor on the bin. Why? Because when the second machine is free, then that workpiece will be taken onto the machine. Okay, till that time it has to wait. So that is a temporary storage. A letter is waiting to be signed. That is a temporary storage. Tools are kept in a rack. That is a temporary storage. Okay. And if it is a permanent type of storage, then it will be, tools will not be kept on the rack. It will be kept in the store, like that it is. Okay. Now, permanent storage. Next is permanent storage. In this permanent storage, here this numbering may not be correct. So I think yeah, 1 2 we have seen here, 3 4 we have seen here, 5 6 it should have been. You see, this numbering sometimes goes wrong. Okay, permanent storage. Permanent storage is inverted triangle. This is the symbol. It indicates a controlled storage in which material is received into or issued from a store under some form of authorization. See, if it is a temporary storage, no writing business is there. Whereas if it is in the store, if you want to get it from the store, you have to give a letter authorization letter, or at least you have to give a requisition slip. Like that you have to give. Okay, it means that the item is kept in custody of some who storekeeper will be keeping in custody. So only with his, if you give him a requisition slip, he will give it. See, normally, the temporary storage or the delay may be a few minutes. Okay, whereas temporary storage can be extended to some hours or some days, weeks also. Okay, to take the item not of permanent storage, not out, maybe it is out of permanent, out of permanent storage, some letter or some requisition or order is required. That is not required in case of temporary storage. So in order to avoid confusion, the word delay is used instead of temporary storage, because if both are storages, there will be confusion. Okay, so one is delay, the other is storage, permanent storage. So for delay, capital letter we are using. For permanent storage, we are using the inverted triangle. Okay, now there are some combined activities also, like operation and transportation both taking place at the same time. So if both are there, operation circle and transportation is a arrow. So this combined activity will be represented as arrow inside a circle. Okay, an example of this is articles are being painted while transported on a conveyor. Some goods are going on the conveyor, at the same time it is being painted. Operation is taking place and all transport also is taking place. So you can show like this. And inspection and operation, this is another combined operation. You see, here now it is represented by a circle inside a square. See, the example is, a sensor is inspecting the dimension whether the part is being machined or when the part is being machined. Part is being machined means operation is taking place. That is circle. But your sensor also is sensing for how much, what is the dimension, when should I stop, like in case of CNC machines or something like that. Okay, not CNC, I don't know, where some places where sensors are used. Okay, like that. Okay, next we will come to this process chart symbols. The same thing, it is put in a table. Okay, tabular form. Okay, operations. So these are the symbols. Wow, how many symbols are there? 1 2 3 4 5 6 7 symbols are there. Okay, operation, with the letter O you can denote, easy to remember. Operation starts with the letter O. Okay, inspection is square. See, operation means it represents an action. Examples are turning on a lathe, loading a job on a machine, writing letter, etc. These are all operations. Okay, whereas inspection means, checking for correctness of the quality, like accounting, checking of the dimension, reading a draft copy of the letter. Okay. See, typing a letter is, or writing a letter is an operation, whereas checking whether the officer is checking from the typist or the steno, whether he has written everything properly, if any mistakes are there, spelling mistakes, grammatical mistakes, that checking comes under inspection. Okay, like that. Okay, transport. Transport means what it is, it informs about the movement of men, material, and equipment or equipment. And examples are, material is sent for inspection. The employee is going to meet the manager. Okay, these are some examples of transport. Here it is a, materials transport. Here it is a man transport. Even he himself is walking, but still it is treated as transport. This transport doesn't mean that he should be sitting on something and he should be going. Okay, then delay or temporary storage, capital D we use, and it is a stoppage in the sequence of events. It is waiting for the part to come from the previous section, or it is waiting for the at the next machine for its turn. Okay, and if the steno is waiting for the officer's signature, then that can also be treated as a delay. And then storage means objects are intentionally retained in a store. Okay, like a goods lying in godown, and tools are kept in stores, etc. Okay, then operation and transport. Operation is performed during transport. Assembly of parts when it is moving on a conveyor. It is moving on a conveyor, you are painting it, that comes under this. When it is moving on a conveyor and you are assembling the things, that also comes under operation transport. And this combined operation, like operation and inspection, combined activity. So this like filling of milk in packets, and checking for leakage, etc. Checking for leakage, or checking for even its weight also. See, it weight, you want to check whether uh, uh, whether half liter is filled or water, or like such things also you can check. That is anyway, if you are checking, weighing. Okay, and that's also comes under inspection. Okay, next let us see the importance of process chart in data recording. Okay, an outline process chart records. You see, now we are talking about outline process chart. You see, if you remember where we started, here in the process chart there are three process charts: outline process chart, flow process chart, and two-handed process chart. Now this fellow is talking, he's talking about the outline process chart. So the now outline process chart records major operations and inspections only. Major, this word is important, major. Small things will not be considered. Where in outline process chart. While a flow process chart records operations, inspections, transportation, storage, delays. You see, this is the second type, flow process chart. Okay, for the activities recorded for men or materials or machines. A two-handed process chart. Now are you seeing there are three things here? You see, this is one, this is the second, and this is the third. Where is it? Yeah, two-handed process chart. These are the three different flow process charts we are talking about. Outline process chart uses only operations and inspections. Operation is O, inspection is square, circle and square. That only outline process chart uses. Whereas flow process chart use all these things, like all those 7 symbols that we have seen. And two-handed process chart, what happens? It records the activities of the workers, both hands simultaneously. Both hands are simultaneously being used. Okay, then it is a two-handed process chart. Okay, then a multiple activity chart shows the activities of more than one A multiple activity chart. This is another chart. You see, multiple activity, uh, multiple activity chart. This is another chart, and a SIMO chart is another chart. Okay, so multiple activity chart shows the activities of more than one subject recorded on a common scale. Why subject they are talking? We can say object. Okay, one object recorded on a common time scale to show their interrelationship. And okay, we will be studying all these things detailedly. Now this is only some outline. Okay, a SIMO chart records the simultaneously on a common time scale dharbligs or group of dharbligs performed by different body parts of one or more workers based on frame by frame analysis of a film. Nowadays we will not be using films and all, we'll simply use our mobile cameras, all this. Okay, now here how many charts we are talking about? 1 2 3 4 5 charts we are talking about. Okay, now let us move further. You see, actually after knowing these things, if you visit this slide once, you will understand in a better way actually what we are talking. Okay, now let us start with the first chart, that is the outline process chart. You see the three charts are there. What are those? Outline process chart, then process chart, and then two hand uh, two hand process chart. Okay, now this is the first one, outline process chart. See, outline process chart has another name also. It is called as operations process chart. Okay, anyway, both these things are starting with O only. This is O, this is okay. Then an outline process chart is defined. Here is the definition. It is defined as a process chart that gives an overall picture. See, the overall picture. See, it is like, from a distance you are looking at a thing. So from small details will not be recorded. Okay, only big activities will be recorded here. Okay, so overall picture by recording only the main operations and like inspection, or main operations and inspections. Okay, operations means those circle objects, and this is inspection means square objects. Only those things, those symbols we will be using. Okay, this chart contains only the symbols of operation and inspection. That's what we are saying. Circle and square only will be there in this chart. Okay, the activities like transport, delay, storage are not included in this outline chart. So it has no concern with where the activity is done or who does it. Okay, as the chart gives only outline of the process and not the complete process, it is called as outline process chart. The operations and inspections are represented in the form of a single flow line. One line, shall I show you one example of this? Yeah, here there's one example. You see, one single line it will be there. You see, either circles or squares only. Here also circles or squares only you will find. This is an example of this outline chart. Okay, so the single flow line. Okay, the operation inspections are represented in the form of a single flow line placed one below the other in the sequence of their occurrence and are joined by a vertical line. A brief description about the activity is written on the right hand side. Brief description given means what, like just I told you now. You see, this is the operation, but what is this operation is written on the right hand side like this. Okay, yeah. The time that will be required for the activity based on estimate is recorded on the left hand side of the symbol. Sometime maybe here they are saying that time is recorded, but some of the things I have seen time also is not recorded. Okay, The summary of activities and time is indicated at the end of the chart. Okay, we will see. When we see an example, we'll understand in a better way how this outline process chart is. Now, what are the objectives of the outline process chart? See, it helps to decide whether furthermore detailed recording is needed or not. See, if you think no, it is further, process chart you have to draw, then you draw. Otherwise, no, it is not necessary. See, this is only giving you the outline. It is used in the design stage to assist in plant layout and location of the concerned departments. It helps to visualize the process in a better way as means of improvement. It shows the relationship between various activities. So these are the objectives of the process chart, outline process chart. Okay. Here are the examples of outline process chart. Now, this is asked in winter writing exam. So like this, the the question may be you draw an outline process chart to replace a car battery. Now car battery should be replaced. What will you do? You see, first you will open the car's bonnet. This is opening is an activity, so you you use the circle. Okay, and the next connect it with the next arrow to the next activity. So next activity, once you open the car bonnet, what will you do? You rest it on the clamp. Okay, that means that bonnet should not automatically fall and close again. So you will use some kind of stopper so that the bonnet will stay, the lid will stay, okay, up. Then you have to go to the battery and loose the nuts, and you have to remove the plug. You have to replace the battery. Replace the battery means you take out the old battery and put the new battery there, and you put the plugs in the battery terminals again, with the spanner and all. You tighten it and tighten the nuts, and then okay, now you have to close the bonnet. Okay, start the car. Okay, somebody should start the car and see whether the battery is working or not. That is a checking. Okay, that's an inspection. That's why the circle is square is given. And then okay, if the car is working, that means what, battery is working properly. Now we have replaced it. Now close the car bonnet. Okay, these are the various activities. First you should know what are the activities that will be coming in the work that is given to you. Okay, see, actually for these things it will not be done. Normally outline process chart and process charts, that we will be doing for the activities that are carried out inside a company, not like these things. But for you to for us, at the learning stage, those things which are those activities which are very familiar to us, those activities we take and we'll try to understand. Okay, so now what, see, the opening the car bonnet is a activity, circle. Rest it on the clamp is another circle. Loosen the nuts, another circle. Remove the plug, another circle. Replace the battery, another circle. Like that, you see, only one inspection is there, whether the car is starting with the power of the battery or not. Okay, that is the inspection. So the inspection square. So now, and also within these boxes, okay, whether it is a circular or square box, what we do is we give the numbers. This is the first operation, second operation, third operation, fourth operation, fifth operation, sixth operation, seventh operation, and this is the eighth operation. And the inspections, only one is there, so here one, like that. So this is the outline process chart. Okay. Okay, this is one example of outline process chart. Now, okay, this is not an outline process chart. Is it an outline process chart? Can you tell me? Here they said an outline process chart. Here they are saying outline process chart, but is it outline process chart? No. Why? Because in outline process chart, this arrow, this triangle and such symbols should not come. If they are coming, means what? It is not an outline process chart, it is a flow process chart. Okay, yeah, here it is written, see, it is a flow process chart. Okay, see, this only is the outline process chart. Okay, in this outline process chart, after writing all these things, no, you see a summary is given here. You have to say summary, and how many operations are there? 8 operations are there. So for operations, circle and write symbol 8, and for inspection 1 square, and how many activities are there? How many inspections are there? 1. So you have to write 1. O 8 and square 1, like that. This is the summary. Okay, but yeah, 1 minute. Okay, this one is not to be studied now, because that we will study when we study the flow process chart. Okay, let us go to the next. Here there are 2 more examples. Now just by looking at the figures, you can find out whether it is outline process chart or not. If only these 2 symbols are there, circle and square, then it is outline. Okay, that much you remember. It is easy to remember which is the outline process chart and which is a flow process chart. Okay, now the question is, this asked in summer 18. You see, the outline process chart to change the SIM card of a phone. And now, sometimes suppose you're not satisfied with some company, because the tower is not good in your house or something, you want to change to another number, you port it, and now you have got a new SIM. Okay, now what you will do? You have to open the mobile's cover of the mobile phone. Okay, nowadays covers are also not, we are opening, with just one pin we will press, and the tray comes out. Okay, whatever it is. See, open the cover of the mobile phone, remove the battery, because under the battery the SIM card was there previously. Okay, remove the SIM card and old SIM card. Remove the SIM card means remove the old SIM card and insert the new SIM card. Put the battery in position, place the cover properly, then switch on the phone and check if the SIM card is working. These are the various the activities and the sequence of the activities. So now out of these things, no, all these things are only operations. Only checking is taking place at the end whether the SIM is working or not. So now 1, 2, 3, 4, 5, 6, 7 operations and 1 inspection. Or they should not have written 8 here. What they should write? They should write 1, because this is the first inspection. These are some mistakes. You should correct it. You should correct it when you are seeing the video itself in your books. You can correct and write it as 1. Okay, so now the summary will be circles 7 and square 1. Okay, now this is another outline process chart. This outline process chart is for replacing the punctured tire. Okay, here they are saying that outline process chart to change the tire to repair puncture. Okay, this is for car. Okay, now you, with the help of screw jack or toggle jack, jack up the car. This is the first. Then you remove the hub or cap of the wheel, because many of the cars, they have a wheel cover. Okay, that wheel cover you have to take, that is cap of the wheel. Okay, then nuts should be opened with the spanners. Once the nuts are, all the 4 nuts are removed, then you will remove the wheel. Then after removing it, what will you do? You will remove the tire. Nowadays, because tubeless tires have come, What we are doing, we are not even removing the removing the wheels. Where it is standing there itself, you are able to repair, because it is tubeless tire. But anyway, this tire is having two balls. Okay, that's why we are removing the tire, remove the tube, or locate the puncture, and mark the puncture, repair the puncture. After repairing, recheck the puncture. No, that's all. They have left it there, and they have not assembled the tire again. Okay, that's bad. Okay, we have to replace. We are saying replace. You should replace it. Replace the tire. Here only they are saying repair the puncture. Here we are saying replace. No. Okay, anyway, so now this is the first operation, second operation, third operation, fourth operation, fifth, sixth operation, and locating the hole now where the leakage is there, that is an inspection. Okay, and then once you do, you have to mark the puncture and repair the puncture and check again. In the water you check whether any air leakage is there. So there are two inspections here. Now how many? 1 2 3 4 5 6 7 8 operations. So circles 8 and squares 2. So this is how the flow process, the outline process charts are drawn. Okay, I think we'll stop here today, for today, and we will continue in the next lecture. Thank you.